Welcome to Study Loop.
Okay, so here's a diagram of the functions. In part A, we want to conclude that f is onto. So let's take an arbitrary element x of C. We know that there exists a y in A, such that f composed with g evaluated at y equals x. This is because of the assumption that f composed with g is onto. Now, f composed with g of y can be written as f of g of y, and notice that this g of y is an element of B, so we have found an element of B such that its image is under f is x, and this means that f is onto. X was arbitrary. Now, for part B, we have to conclude that g is 1 to 1. So let's take two elements, x and y, elements of A, and let's suppose that g of x is equal to g of y, and we want to prove that x is equal to y. So let's consider, well, if this equation is valid, then we can take f on both sides. We have this, and well, we can write f of g of x as f composed with g of x, and the same on the other side. And because of the assumption that f composed with g is 1 to 1, we conclude from here that x is equal to y. And well, we started assuming that g of x was equal to g of y, and we concluded that x was equal to y. That means that g is 1 to 1. And now for part C, we have an if and an if. So the first part is to prove this. If f composed with g is a bijection and f is 1 to 1, then we have to prove that g is onto. So let's consider an arbitrary element of B. Remember that the domain of G was A and it goes to B, and F goes from B to C. And yeah, so let's consider an arbitrary element of B, denoted Y, and then let's consider its image under F. So f of y is an element of C, and since f composed with G is a bijection, in particular it is onto, then we can find an element set of A such that f composed with G evaluated at set is equal to f of y. Now f composed with G can be written as f of G of z, and this is equal to f of y, but using the assumption that f is 1 to 1, then we can conclude that G of z equals to y. And so we took an arbitrary element of B, and we saw that there's an element of A such that G of z is y, so that means that G is onto. Now for the other direction, let's assume that f composed with G is a bijection and that G is onto, so we have to conclude that f is 1 to 1. To do this, let's take two elements, x and y, elements of B, and because G is onto, we know that there are elements W and Z, elements of A, such that G of W is x and G of Z is y. Now let's suppose, to prove that f is 1 to 1, let's suppose that f of x equals f of y. This means that f of G of W equals f of G of Z, but this can also be written as f composed with G evaluated at W equals f composed with G evaluated at Z. But since f composed with G is a bijection, and in particular it is 1 to 1, then we can conclude from here that W equals Z. And if W equals Z, that means that G of W equals G of Z. and g of w was x and g of z was y, so we conclude x equals to y. So we had f of x equals f of y, and we proved that x has to be equal to y. That is that f is 1 to 1.